Hello, Shagatha Unknown here. Welcome to another Rust coding stream here on the 9th of January 2023, local time 17. And I forgot to pull up my stream manager on my phone. Give me just a moment. Use that to help monitor things. All right, there we go. I knew I was forgetting something. All right, so what did we do last time? What are we up to now? Well, we kind of finished refactoring a lot of the map stuff. What is this spawn? What the hell is this spawn? That was brutal. You just rest. That was distracting because it was such a brutal spawn. So we basically finished doing a lot of refactoring to the map generation code and basically setting it up where we could do different kinds of layers. So previously we had two different kinds of layers, which was the initial and the meta map builder. Well, we still do, but it was limited to only certain kinds of maps that we could actually use that on. And we started expanding some of the different maps to allow them to also be meta builders. For example, Cellular Automata is now a meta map builder as well. So in a case like that, we'll actually go look at it real quick. Cellular Automata. We can see that we import meta map builder and initial map builder for it. And we pulled out like this apply iteration code. And in this case, we apply iteration 15 times if this is an initial map builder. Because we're going to call this build function here. But in the case of the meta map builder, we just apply an iteration to the map that we already have. And we only do it once. We could potentially do it more than once if we wanted, get very different results. But that's an example. We did that for a lot of algorithms last time. So there's a lot of very boilerplatey stuff going on, but it produced some pretty cool results. Really expanded things out quite a bit. So let's go ahead and take a look at improved room building today and see what this has in store for us. So in the last chapter, we abstracted our room layout, but kept the actual placement of the rooms the same. They're always rectangles, although this can be mitigated with room explosion and corner rounding. This chapter will add the ability to use rooms of different shapes. So we're going to look at a rectangle room builder first. It's going to accept a set of rooms as input and then output those rooms as rectangles on the map, exactly like the previous editions. We'll also modify Simple Map Builder and BSP Dungeon Builder to not duplicate the functionality. So we're going to make roomdraw.rs, and then we're going to put a bunch of this boilerplate code in, which is very similar. It's actually the same drawing functionality found in common.rs as apply room to map, wrapped in the same meta builder functionality we've used in the last couple of chapters. Nothing too surprising here. So I'm going to go back to the usual philosophy. You should not copy paste code that you have not written before. However, this is code that we have written before, so for the sake of brevity and not spending as much time doing repeated things here, I will bring in and copy that existing code, and we'll just walk through it for a moment. So we go ahead and set up the room draw. You saw me pull it into mod.rs. That way we would get like completion and stuff in here, assuming it works properly. Room draw is there, good. Not seeing anything, so let's... Okay, yeah, we're good. It's just, there's nothing for it to even tell me about. That's good. I usually expect, like, look at most of the files have some yellow. So I'm used to it. But here we go. We have room drawer, which is a weird word to say, but it takes, it has a build map function because we're doing a meta map builder impl. And the room drawer calls the build, or it defines the build function that build map is calling. And all it does is it tries to get the rooms, and assuming it has them, it iterates over them and actually creates the stuff on the map, right? So for the tiles in the rooms, it goes through and sets the map tiles to be floor. So that's all there is to it. What we can do here is something that, I've done a few times before. We'll remove that there. We'll put rooms here. And we'll do this. And we'll get rid of that. And we'll get rid of the if. We'll add a semicolon there, and I think I did everything I needed. Yeah, we could do that. It's a little bit cleaner, but it's not a big deal either way. And that construct, the let else, did not exist when this was written anyway, when this tutorial was written. So simple enough. We've definitely seen this before, as it just mentioned. So we're going to be cleaning up some of the previous stuff. In BSP Dungeon, we're going to remove the line referencing apply room to map. So let's go to BSP Dungeon. And apply room to map is now gone. You can also remove the take snapshot because nothing's happening, right? Because nothing's being applied to the map, so no changes are actually there. So now we're just left with pushing the rooms and doing the subrects to continue our algorithm here. And we're going to update is possible to check the rooms list rather than reading the live map. So is possible is going to have some changes. Because now we haven't actually written anything to the map. So we're actually going to add, where is possible? Well, we'll just change it here. Instead of map here, we're going to do build data. And we'll pass in the rooms as well. And we could see up here is where it actually gets mad at us. So build data, it's no longer going to be build data.map, it's going to be build data. And we'll pass in rooms as well. And we should be good there. Although I was typing this a little bit blindly as I did that, and what I'd like to do here is change that to a slice. And everything else is fine. So we could say it looks like an array. This is a reference to an array or something. It's a slice, and that still works with a reference to a vec, as we just saw. So now we have a few things to update here. Build data dot map. All right, and we're not quite done here though, because we actually need to look over the rooms. So let's see how we modify this. Can build, we're going to iterate over the rooms. So this is another case for iterators where we could use some of the functions on that and make it a little more functional. So we're saying if any room, so there's another thing I would kind of suggest here is if you want to do it this way, do a break, because what if the first room has an intersection? Yeah, what if the first room has an intersection, right? But then you have like 30 rooms in the list. Yes, 30 is not a big number for computers. It's not going to care. But without the break, it's going to keep looping through even though you don't need to do any more work. All you care about is that false or not, right? Is it true or false? Because you started out as true, and then if it changes to false, it doesn't change back. So once you get that first initialization or that first assignment to false, you could just, you're done. We could also do rooms.iter. And then we could say dot all. And now we want to say, well, we'll do it another way. Any r.intersect. Oh, I didn't make the closure. So this is going to be r.intersect. And then we're going to need an if in the front of this. We could do that as well. If any rooms intersect, can build as false. Basically, it returns true if any of these return true, right? So if it returns true, then we had an intersect and can build as false. It's simply a way of kind of removing the loop. I mean, it's still looping under the hood, but it's a way of removing the explicit loop there with the same behavior. Hopefully I didn't make any typos there. Nothing's mad at me. Hopefully I didn't flip something. So now for y and expanded y2. Yep, that looks fine. But index is that if build map tiles, okay. And build is false. And then down here, we also return can build. Well, I have another suggestion even. Would you not just want to return? I mean, I might be getting a little too in the weeds here, but would you not just want to return here? If can build is false, it's never going to be set to true again. And in fact, that would happen in any case where you turn can build to false. We're not modifying anything. Yeah, I kind of feel like that would be an improvement. It would stop us from having to loop through, although these aren't going to be expensive loops. But I'm going to keep my code in spirit closer to what's in the text, despite the fact that I changed how we're doing this. Okay. Just things to think about. If can build can never go to true again, then the moment you set it to false, you could quit. Because you're returning it. You're returning it at the end, so there's really no reason to keep going. Another way we could do it is we could say outer loop. Is that not it? Yeah, it's that. I was about to say, I think it's, yeah. So we have a label here called outer loop. And then when you set can build to false, you can actually say break outer loop like that. And it's a nice way because normally break is going to hit the scope that you're within, or I mean, and you can't break an if statement. So it's going to flow up to the first loop that you're in, right? Which is going to be this inner loop. But you could do that to break out of the outer loop and just say, no, we're done. So that's a nice way that we could do that if we wanted. But again, I'm going to just, for keeping things more in the spirit of what's in the text, I'll talk about some of these ideas as I see them and we'll go on. But if I were writing this, I would do it differently for sure. Unless I can see a reason not to. So in simple map.rs, what are we going to do? Where is simple map? Apply room to map and take snapshot. We can kill that. And why do we have it twice? Yeah, so in their case, they say if okay, rooms.push. Now remember, I wrote mine a little bit differently using the using this construct as well. Could we switch this for any? I have to think about what we're doing. So we're saying if no rooms intersect. You could, but I think I'm fine with this. What you could do though, it would actually be more performant. If any room intersects and not that, and that would actually get you a little bit more performance. Because once we find one room that intersects, we can break this hidden loop that's part of this iterator and any. So it's a little bit more efficient. We'll do that. That's kind of my change here, so we'll do it my way. Okay. And let me double check one thing. Yeah, let me expand that one time. Bit large, but expand it one time. Okay. So nothing is using apply room to map in common RS anymore, so we'll go to common. I'll open my palette here and type in common, and we'll get to it here. Apply room to map, boom. Hey, what's going on, Rose? I got you on that drink. Oh, these are mad because they're pulling in apply room to map, which no longer exists. So that's happy now. And now we're going to go to the random builder in our mod here, in our map builders stuff. Where is random builder? I think it should be, oh no, it's here, okay. Oh, we're just gonna hack something together, right. So we'll just plop that in here. And we never pulled this in. 3 exams, I hope they go well for you. That seems quick. That's a lot, I hope they go well for you. Good luck. And we'll run the project. Pretty straightforward. Yep, not much to it. The point, it is a refactor, so it's just taking the same behavior and shifting it to a better way of doing it. So, as it says, if you cargo run, you'll see our simple map builder run just like before. Now we're going to look at circular rooms. So simply moving the draw code out of the algorithm cleans things up, but doesn't gain us anything new. So we'll look at adding a few shape options for rooms. We'll start by moving the draw code out of the main loop and into its own function. So we'll modify room draw. What kind of exams you got? What are you having to do? All right, so in room draw, we're going to make a new function. Is it going to be... yeah, it's in the impl. So we're going to do rectangle. And we're also going to do this here, build. Math, history und a German exam. A Prüfung von Deutsch. Sprechen Sie Deutsch? Ein bisschen? Same. I studied it a long time ago. I don't remember enough. All right, so we have build. Oh no, wait, we already have build. Sorry, I was thinking we were already doing circle. I just went on autopilot for a moment. That's what, okay, something threw me off, but that's why. All right. Forgive me. They ordered it in a strange way that threw me off. So they're actually putting rectangle above build, and it just broke my brain. For what? Okay, no, this is the same code, so I'm just going to copy that. Where's the loop end? Right here? So for y in room, yep, for x in room, let index, if index is blah, 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 all that is the same. Cool. Okay, we look like we're good to go there. Up here in this, we're also going to want to actually apply, like put the rectangle, like call the rectangle code. So self.rectangle and just give it build data and room. And now something I was thinking about, well, actually, we'll go ahead and run it and we'll see that it behaves the same way. But something I was thinking about is that unless we have some specific new data that we need for circles that we can't generate on our own, that we can't figure out, we'll probably want to have the same API to make rectangles and circles. As far as a computer is concerned, they're not terribly different based on how we can generate them. So looking ahead now, I can actually see that we are using like the same API. So if I copy this and start making a circle, it still takes immutable reference to self, it takes build data, and it takes a rectangle. Because we can use a rectangle to make a circle, kind of. So we're going to say let radius equal I32 min, and it's going to be the min between room.x2 minus room.x1, or room.y2 minus room.y1. As F32 over 2.0. And the center is going to be the room.center. Very easy. So what we're saying here is, what is smaller? Let's look at the first line to figure out the radius. What is smaller, the X or the Y? And whichever one is smaller is going to be our radius. And we're going to get the center point of the room. We're actually going to convert that into a RLTK point. Yeah, you're going to need to get that laptop taken care of. A is too useful of a key to not have it not working. So we're going to do a loop over this stuff here. I'm going to copy this. It's going to be a little bit similar to start out. So loop over Y and X. And then we're going to get the index. And then this is where it really changes. So I'll remove this because we got to do some more work here. Distance alg, we're going to use Pythagoras. And it's going to be a distance 2D. The end is going to be, you scroll over, it's just a point on XY, so. Beautiful. Okay. So if the index is greater than 0 and index is less than build data.map.width times build data.map.height minus 1 as you size, and distance is less or equal to radius, then we set that to a floor. So let's try to make sure we understand this. It's not the most crazy thing ever, but we're basically figuring out again for the radius, is the X or the Y portion of the rectangle smaller, right? And so if X is smaller, we're going to pick the X value, like the width of the rectangle, and then we divide it by 2, right? Because we're getting half of it because it's a radius, not a diameter. Then we get the center of the room. We convert that to a point. And then what we do is the high-level version of what's going on. For every part of the rectangle, we check to see if it's within the radius of the center. So we do this distance 2D from the center point to the point that we're looking at. And then we make sure that that distance is less than the radius. We also check for the map bounds and we, check for the index. But the most important thing is that distance is less than or equal to the radius. And that's how we know that it should be part of the circle. Like I said, just because it's a circle doesn't mean we can't use a rectangle to build it. As goofy as that sounds, it's data. I always say data is just data. It's up to you to tell the computer how to use it, right? How to interpret that data. So if we actually put circle in here and call it, we should see our rooms look quite a bit different. Very different. So let me double check one thing. Yeah, some of them look a little goofy. I want to make sure I didn't miss a symbol somewhere. x2 minus x1, y2 minus y1, that's good. Room.center. Room.y1 up to and including room.y2. x1 up to and including x2. We do this index. Center point to xy, that's correct. Index is greater than 0. Index is less than build data, so it's width times height minus 1. Yep, that's good. Distance less equal radius. Yeah, that's good. I think it's just we got some goofy sized rooms. Because it looks a little, I mean, it looks the same, but also a little bit better on the example. So we'll show that in a moment. We'll run it one more time. No, I'm getting some, like, it's not rounding all the corners correctly. I'm going to try a quick brute force here. I just brought in the, I just copied in and brought it in, and I'm going to see if it looks any different. It is recompiling, so something might have changed. Yeah, so there is a, hang on. Distance alg Pythagoras, distance 2D. Most of it's not changing, though. Oh, wait. Here's what I actually need. Let me compare them side by side a little bit. I think there's just a simple typo somewhere. Because we definitely just got some different results. Center 0, center 1. Let me just put this in here, see if anything changed. What is the difference? Because I don't see any. All right, let me try this. All I did was bring in these 3 initializations. It's back to the original. Did I type something wrong on one of the loops? Doesn't look like it. Loop conditions. Oh, no, I did. I put a +1 there. And that explains why it was always on the left side of the room. There we go. That was a stupid mistake. Where was I looking at that had a +1? Why did I type that? Oh, is it? It's from the rectangle code. I didn't remove the +1. I copied it from the other code from the rectangle builder. And of course, we don't want the borders of the rectangle. There we go. We don't want the borders of the rectangle included, so we have the +1s on there. Of course. That actually raises one more question. Should rectangle be... Yeah, rectangle's good. Okay. Apologies. But now we can do rectangle or circle. So we're going to pick a shape at random. So it'd be nice for round rooms to be an occasional feature. So we'll just modify build a little bit to make it roughly 1/4 of the time. So in build, instead of just doing this here, we're going to want to use the random number generator. And then we're going to want to do a roll. We'll do a 1d4 and we'll match on the room type. And then we'll say if it's a 1, then we'll do circle. Otherwise, oh, I put a semicolon by accident. Like, why are we not getting the completion? And there we go. Now we'll remove the self.circle there, and now it's very random. So if we cargo run, let's see what we get. We should get a nice mix of the two. Well, a favor to rectangle, but we should see a circle or two pop up. There we go. Good stuff. We'll run it one more time. It is nice. It's a lot more variety in the maps now. Adding more and more variety, chapter after chapter. It just makes it a lot nicer for, you know, everything. Like your game is much more enjoyable. So we're going to go back to the mod and we're going to just fix this thing back up real quick because we're actually done. So the random builder is back to what it used to be. So in the random room builder is where we're going to actually have this new code. So we go up to random room builder and we have the sort roll. We're going to now, before we do the corridors, we're going to add the room drawer. It's a weird word. Room drawer. And that's really it. There's like, I don't think anything else to do there because the other things aren't drawing the rooms in anymore. So now it's this that's drawing the rooms in. And there's nothing else we have to add. We get the full gamut of random room creation, but with the occasional round instead of rectangular room, adding a bit more variety to the mix. And there we have it. That is the end of this session on improved room building, but not the end of the stream, because that's too quick, 33 minutes. I know that looked ugly for a second there. So let's look into better corridors. I'm going to look at the scroll bar over here. It's going to get a lot smaller, I think, but it's not terrible. So let's look into doing better corridors. And that way next time we can go to like doors and maybe decoupling, but that's going to be longer. So let's do better corridors. Oh, nearest neighbor. Yeah, this is going to be fun. Okay. I thought I might do 2 sessions today, 2 chapters today. And yeah, I think it's going to work out just fine. So the corridor generation so far has been primitive, featuring overlaps. And unless you use Voronoi spawning, nothing in them. This chapter will try to offer a few more generation strategies, in turn providing even more map variety, and allow hallways to contain enemies. So the new corridor strategy is going to be the nearest neighbor. That's reminding me of some algorithms, K nearest neighbor. One way to make a map feel more natural is to build hallways between near neighbors. This reduces but doesn't eliminate overlaps and looks more like something that someone might actually build. We'll make a new file. So we're going to be rooms, corridors, nearest. And we'll see what kind of scaffolding we put in there. So I might copy it. I might step away for a moment. Go take some medicine real quick. I'll give it a few minutes and then I'll make the decision. All right, so we've got everything set up for that. Well, the starting scaffolding is pretty easy. So no bones, like no problems copying that. Now we're gonna do the impel. I'm just gonna grab this as well, because why not? There, now we have the basics, and we don't have corridors, so we'll have it generate that. And self, and an unused RNG. And build data. And I don't think it's going to return anything, so it's just modifying. It is a mutable reference to self, so I need to fix that up. Alrighty. So, yeah, again, nothing else is really special about this. We've done this probably a couple dozen times now at this point. Maybe not a couple, but about a dozen times at this point, if not more. No need to comment on MetaMap Builder and stuff, right? Very basic if you've been following along. And if not, it's in the videos. It's on YouTube now by this point. Okay. So we're going to actually implement corridors here. So we're going to do the let else construct here to get the corridors. Or to get the rooms, I mean. So we're going to do let some rooms equal build data dot rooms dot clone else we'll go ahead and panic, which I don't really like doing, but this is the tutorial. I commented on it like every time. I'd rather try to default to some behavior that's better than not working. Because a player would never know that you had a bug probably, and they would just have a map that they could still play. I kind of prefer that, but we'll let the panic slide. So we're going to have a hash set of U sizes as a way to just keep track. We've called it connected here, so it's going to be a way to keep track of what's actually been connected or not, so we don't reuse the same one. And we're going to enumerate over the rooms, keeping track of I being the enumeration and room being the room that we're actually on. And we're going to do a familiar construct, a tuple of a U size with an F32 for the distances. Typically where the U size is referring to an index and the F32 is our actual distance value. And we'll make a point out of the room center. We could do this, I guess. Okay. It's not mutable, I guess, so it works, yeah. So we're also going to then loop over the rooms a second time so we can compare to all other rooms. And we're trying to make sure that everything gets connected. So when we're doing the second loop now with J and other room, if I does not equal J and connected does not contain J, then let other center equals other room dot center, and let other center point equals RLTK point new other center dot 0 other center dot 1. Just rip the values out, and then we're going to do a distance. Pythagoras again dot distance 2D, and it's going to go from room center point to other room center other center point actually. Scroll that back over. Let me close this too. That'll help. So we make a distance, and then we're going to room distance dot push j distance. So we're going to do this for each room. Nothing's connected yet. Well, something may be, but we haven't actually connected anything yet. So it's going to be after we loop through do the second loop. Basically, the first loop is like, this is the room we're currently on. Let's compare it to every other room, and then build up this vector of distances to rooms that are not yet connected. That's the high level view of what's happening. If not room distance dot is empty, we're going to do a sort by. And we're just comparing A.1 to B.1. So what is A and B? That's from the room distance, which is that vec that we built up, and that's the U size and F32. So remember, the U size would be our index, which we see here as J, the index from this second loop. And then the distance is the F32 value we get from the distance algorithm. So distance, being the second part of the tuple, is our A.1 and B.1. So we're sorting by the distance. So we're going to get the closest one first, which was the algorithm here. We're trying to find out nearest. We're doing it based on like the nearest. So that makes sense. We should be doing that. So if room distance is not empty, we sort, let dest center equal rooms, room distance 0 dot 0 dot center. Right, so we'll break that down in a moment too. Draw a corridor. It's going to be mutable reference to build data.map. Not to owned. Where'd that come from? Room center dot 0, room center dot 1. Why are you giving me to own today? And there we have it. Okay, and we draw the corridor, we insert the room we're currently working on and connected, take a snapshot. So what does it mean to draw the corridor and stuff? This dest center is interesting. So rooms, this is weird, but it's actually not bad, because we're getting the room distance that was closest. Remember, we sorted room distance. So room distance 0 right here is the closest room. Dot 0 is the index of that room. So we're getting the index of that room to index into rooms, and we're getting the center of it. So that's the center of our destination. So now we have the center of the current room, the center of the destination room, and we can use that to draw a corridor, and again, insert this room into connected. So we'll read the tutorial text as well, along with my high-level breakdown. There's some boilerplate with which you should be familiar with by now, so let's walk through the corridor's function. We start by obtaining rooms, the rooms list, and we panic if there isn't one. We make a new hash set named Connected. We'll add some rooms to this as they gain exits, so as to avoid linking repeatedly to the same room. For each room, we retrieve an enumeration called I, the index number in the vector, and the room. We create a new vector called room distance. It stores tuples containing the room being considered index and a floating point number that will store its distance to the current room. And we calculate the center of the room. It's stored in a point from RLTK for compatibility with the distance algorithms. For every room, we retrieve an enumeration called J. It's customary to use I and J for counters, presumably dating back to the days in which longer variable names were expensive, and the other room. If I and J are equal, we are looking at a corridor to/from the same room. We don't want to do that, so we skip it. Likewise, if the other room's index J is in our connected set, then we don't want to evaluate it either, so we skip that. Then we calculate the distance from the outer room divided by I, to the room we are evaluating. Oh, no, not divided by, yeah, because I was like, we didn't do that. Room, it's just saying the outer room is room/I, as in two names for the same room. And then to the room we're evaluating, other room or J. So we push the distance and the J index into the room distance. If the list for room distance is empty, we skip ahead. Otherwise, we use sort by to sort the room distance vector, with the shortest distance being closest. Then we use the draw corridor function to draw a corridor from the center of the current room to the closest room. All right, one moment. Sorry about that. One thing that's standing out to me, and I was thinking about it as I was reading, and as I was even writing the code, is this bit here. If J is in the connected set, then we don't want to evaluate it. But we allow... No, that's... Oh, no. Yeah, it's still kind of throwing me off. We only insert I into the connected set, but I and J have both been connected. Well, no, yeah, of course, you can't do that. Never mind. As I'm about to describe it, it makes sense now as I start to explain it out loud. This is what they call, it's kind of like rubber ducky debugging, right? Where you start to explain something and you see the flaw, or you find out the problem when you start explaining it. So in this case, the flaw is, well, if you put J in here, you'd never connect more than two rooms together. And so, of course, yeah, you need to allow connections to be joined to at least one of the two rooms. I mean, I guess theoretically you could put J in here, you'd get some weird behavior, but you would still get multiple connections at least. But if you try to put both, then yeah, neither of them would be in the set. And up here, you would never evaluate them again. And that'd be a problem. Okay. So now we're going to modify random builder to use the algorithm. So I'm just going to copy this in and we'll cargo run it and see what it looks like. How did you lose part of the A? Like the switch of the key? The actual switch? All right, nearest corridors, bring that bad boy in here. And cargo run, let's go. All right, we hit a snag somewhere. Probably, yeah, probably bad indexing. So it seems like... It seems like we ran it again. You know what I think is happening is either I missed a piece of code that breaks out of here, or there's some kind of a bug. The first thing I'm going to do is just copy the whole function, paste it over mine, and see if it happens again. I copied one too many. There we go. I just want to make sure that this problem is... Okay, no. So I did make some kind of a typo somewhere. Let me run it again. This should be back to what I had before. Or do I have to go back again? Okay, yeah. So it is on this line here. It's the indexing. The len is 0, but the index is 0. So rooms is empty? Why? That doesn't seem right. Let's see. I'm gonna double check a couple things here. Room center point. Room center 0 and 1. For J, other room and rooms.iter-enumerate. If J, or if I is not equal to J, and not connected.contains J. Other center is other room.center. Other center point is based on other center. Distance, room center point to other center point. And then we push J and distance. Wait, which line is mad? Or not line, but which? It's room distance. Right? Oh, you know what? Maybe. We'll do log. Nah, we'll do print line. Actually, I shouldn't even print the len. I should just print the whole thing. Debug print it. Oh, yeah, that's the thing. Okay. I did something stupid. They did put this inside here. So earlier, when I first started debugging this, I said I either typed something wrong or there's no check. I'm saying there's no check to see if we should keep going or not, or to break out or anything. No, this was it. I thought there was a closing brace, and I thought they did this other code after. No, so that's perfectly fine. Yeah, that's gonna fix it now. Because I was like, why would we do that? And I'm looking at it, I'm like, no, that is the problem. I was like, wait a minute, we do have the check. Cool. Yeah, so simple. I think what happened is I said if not room distance dot is empty, and I did that, and I was like type some stuff, and then when I looked back over, I just started going. I was like, all right, we're typing now. I think that's what happened. Yeah, that's good. Man, I'm having struggles today. All right, so we're running it now. It gives nicely connected maps with sensibly short corridor distances. As we just saw, we could take a look at the tutorial text here and see an example as well. And now, yeah, overlapping corridors can happen, but they're a lot less likely. Corridors with Bresenham lines. Instead of doglegging around a corridor, we can draw them as a straight line. It's a little more irritating for the player to navigate, more corners, but can give a pleasing effect. And this is something I talked about before that we'll probably do. So we'll have rooms, corridors, lines.rs. I'll copy the boilerplate for us here. We'll add that up here. And we'll actually bring in this as well. All right. And so I don't have to do it again. Let's extract our rooms by borrowing that existing code. Boom. All right, so we get our rooms. Nice and easy. Practically a one-liner. And we're going to do a lot of similar stuff, actually. We're going to do a lot of similar stuff. So I'm going to copy this whole thing now that I'm looking at it and try to be careful and make sure I don't make any mistakes when doing so. Because that's happened today where I copied something from one place to another and then had a slight issue. So we'll let draw corridor, we'll let it be mad for a moment. Let's take a look up at, just go line by line. So we're going to have the connected hash set. We're going to loop through the rooms. Same thing. We're going to get the distance, room center point. And yep, that's all there is to that. J and other room, similar to the other one. If I is not equal to J and connected doesn't contain J, then we're going to do the other one. We're going to get the distance, and that's it. We're not going to sort. Oh no, we are. Yeah, we're still going to sort. So that's the same. And we're going to get dest center. So everything is the same up until draw corridor, because that's our dogleg corridor as it's being described. We're going to want to do something different. So we're going to say let line equal RLTK line 2D. Now we also have line 2D Bresenham. Interesting. I don't know why we're not using it. We'll do RLTK line alg for algorithm. Bresenham. And it's going to go from room center point to the dest center. So it's going to be RLTK point new dest center 0 dest center dot 1, and we're good. After that, that's our line. We actually need to draw the line for cell in line.iter. So we're going to loop over the pieces of the line. We're going to get an XY index from that, from cell.x and cell.y. and set the tile type to floor. Everything else remains the same. The text even says as much. It's almost the same as the previous one, but instead of calling draw corridor, we're using RLTK's line function to plot a line from the center of the source and the destination rooms. We then mark each tile along the floor, along the line as a floor. If we modify random room builder, like so, make sure that's saved. We'll pull this in, straight line corridors, boom, let's go. And run it. Hopefully no crashes. Look at that. Very different. Very, very different than anything we've had before. And this is something I was hoping we would get previously. So let's watch it one more time. Like it. I like it a lot. Okay. So we're only about halfway done with the new corridors. So of course we have more. Let's take a look at their example here. Their little one that does the angled, the straight line corridors. Pretty cool. Now we're going to store corridor locations. So what I'm guessing, without even having read it yet, I'm scrolling up so I can't read it. I'm guessing we want to be able to spawn things in the corridors, as we've already talked about. So previously we've been storing rooms in our builder map, like our state, you know, we store the rooms, and I'm guessing we might want to also store the corridors now so we can use those to spawn within. We might want to do something with our corridor locations in the future, so let's store them. In map builder mod.rs, let's add a container to store our corridor locations. We'll make it an option so as to preserve compatibility with map types that don't use the concept. Alrighty. So back here, we need to get to builder map. And we're going to put it right after rooms, which kind of makes sense. It's a bit of a beefy, data type there. A vec use size. We'll see how it's utilized. Oh no, I understand how it's utilized. This inner vec usize is probably going to be the indexes of a corridor, and this outer vec is going to be every corridor. That makes sense. We'll need to adjust the constructor to ensure corridors isn't forgotten. So corridors becomes none. And in common.rs, which I think we still have open, we'll modify our corridor placement. Yeah, we'll modify our corridor functions to return corridor placement information. So draw corridor returns a vec usize. And the tunnels also do that. So now everything's mad. Very, very mad. So we have to address that. At the end of this, we'll return corridor, but we don't actually know what corridor is yet. So I think what we're going to do is we're going to put these tiles as we modify them into a corridor. We'll make a new vec, and we'll just slide right down here. Corridor.push IDX as usize. Beautiful. That's all there is to it, right? Going to be the exact same thing for here, essentially. Very, very simple change. Every tile that we turn into a floor when making the corridor just goes into our corridor vector, and then we return it. So then here, we'll do it where this happens, but I'm seeing a little bit of a change here. So I'll add this little bit of a change. We have the index, and then it also says if map.tiles IDX not equal to tile type floor, then we do it, which doesn't really matter because if it's a floor, it doesn't change anything. But I see why it matters a little bit. It could result in like extra spawning or something. So I think I commented on this when we wrote Draw Corridor, that I was like, maybe we should check, but it's not really a big deal because the maps are pretty small. It's a one-time thing, so if it, you know, reassign, if it just duplicate assigns something that's already a floor, like whatever, not a big deal. But I mean, this is better, more thorough. Okay. And that's really all there is to that, but we're going to have to use it now, right? So the text says, notice that they are essentially unchanged, but now return a vector of tile indices and only add to them if the tile being modified is a floor. Actually did... Oh, there might be another change going on up above as well. Yeah, I missed it because it was so simple. So, and map dot tiles idx as usize not equal floor. What's it called? Tile type. Make sure I didn't jack that up. Okay. There we are. Do that on both of those. And I wonder if they're going to give the same description that I gave as to why we're keeping track of it. Let's find out. They only add them to the, if the tile is being modified as a floor. That'll give us definitions for each leg of a corridor. Now we need to modify the corridor drawing algorithms to store this information. In rooms corridors BSP, modify a corridor's function. Okay, so let's get over there. Our corridors function. Are we actually returning it? No, we're just assigning it. So just before the loop here, we'll make our corridors. I'm betting we could just not even put the type in here. It's currently unknown, but once we start putting things into it, it will have to be. It'll have to be known. So we'll say let corridor equal whatever we get from draw corridor. And then it doesn't really matter too much, but before we take the snapshot, we'll say corridors dot push corridor. That word is starting to lose meaning to me. And at the very end, so now it says, it already says we have a vec usize because it knows that this is a vec usize and we put it into corridors, so it already figured it out. And there we go. We just set build data.corridors to be some corridors now. And that's all there is to it. So we'll do the same for rooms corridors dogleg. Very similar. Let's make a new vec and go down here. We're going to have a couple of them here because we're doing it a little bit differently. Go to the end of that line. Okay. So we're actually putting C2 on the end of C1, and then we're slapping that whole thing into corridors. Now, I don't know if we necessarily need, we probably would want to. You could make an argument that you'd still be tracking if you just push twice. You'd be treating like a dog leg, as we're calling it, like the L-shaped corridor, you'd be treating it as two different corridors. And if you wanted to keep track of how they're linking up between rooms and stuff, you would lose some of that information. So this is probably better, but it's also probably not 100% required. You could probably just push them in separately, but it really depends on how you're using it. So then at the end here, after this loop, we add that to our build data, and we're good. So the text actually says, you'll notice that we append the second leg of the corridor to the first, so we treat it as one long corridor rather than two hallways. We're going to apply the same changes to our newly minted rooms corridors lines. And so we make connected, and then we come down here. Let mute corridors equal vec new. And at the very end here, that's enough to already tell it what corridors is. And then I got to make sure, I guess the only place we use it's here, probably. Oh no, because we're doing multiple corridors, right? So we're gonna keep doing this. So we make a line, and then we say let mute corridor is a new vec, and then for each cell we get the index. Scoot that up into here, and then we will push that corridor in. And then down here where we do the connected, we do corridors push, or yeah, the push corridor. Now I want to double check one thing on dogleg real quick. Oh, yeah, we don't have to do it on dogleg. We don't need to check for tile types because that's right, we're handing it off to apply vertical and horizontal, which already does it. Okay. So that should be it for that one. So we also need rooms corridors nearest, which is another new one we just did. So right around connected, we'll do let mute corridors equal vec new. And then at the very end, we'll put that into build data. And very similarly to the other one, but we get to skip some steps. Let corridor equal draw corridor because we're using something that already returns the corridor. Once again, that word has already lost all meaning to me now. Corridors.push corridor. And we're back to the text for a moment now, so let's take a look at it. So, okay, so we have corridor data, now what? Well, one obvious use is to be able to spawn entities inside corridors. So we'll make a new room corridor spawner just to do that. It's going to be based on, okay, this was based off of room-based spawners, copy-pasted and changed the names. Then the if let was replaced with corridors, and instead of spawning per room, we passed the corridor to spawn region. Entities now spawn in the hallways. I'm going to say, because of that, I'm just going to copy this and make slight modifications to my taste. And we'll read over it as I always do, but it's basically something we've already done. So I don't like... Actually, this if let is okay. I still think I kind of want to modify it. Remove some of the nesting. So what we'll do is we'll come out here. We'll say let some corridors. Is this going to work the way I want it to, though? Yeah. I think it's a little bit nicer. It's not terrible either way. Metamap builder. Oh, that's very simple. We've done that 100 times now. So the build, we just rip our corridors out instead of our rooms. Corridor-based spawning only works after corridors have been created. If we fail. And then for corridor in corridors, we get the depth because we actually need the map depth for our spawner. And then spawn region over the corridor. So the area is C here, which is just, remember, defining a vec of U size is just saying where do we spawn things, right? The U sizes are the indices at which we spawn. And that's all there is to it. So very simple code here. And we're going to test it by modifying the random builder. And we're actually almost done. 2 lessons in an hour and 20 minutes with bugs. With me doing dumb things twice. How about that? I mean, assuming this works right away. All right, let's look around a little bit. I mean, I already see we have a sword in the corridor here. So I think it's pretty safe to say that it is working just fine now. I mean, we have another thing in a corridor here. Here. So yeah, I think we're good. Cool. Now what I think we might end up doing is making it where the corridors are random between lines and dogleg and stuff. Maybe. Because we have straight line corridors. Well, I guess we're already doing some of that. Yeah, we just need to add the new line one and stuff. That's right. Dogleg. Yeah, okay. See, I'm losing sight of things. So once you are playing, you can now find entities inside your corridors, which we just saw. So we're going to restore randomness. Random builder, we're going to fix it. I don't care enough to retype it. So that's fixed. I know you didn't see me do it, but since everything we've worked on here has been room-based, we'll also modify random room builder to include it. We'll expand the corridor-related section. I'm just going to go do that real quick. Let corridor roll. I'll replace that. And now if I click back over, we have here... Well, actually, I'll undo that. We went from this to this. So we just have extra rolls here with the new corridor logic now. And we also have the corridor spawning, so we don't always spawn. We have about a 50% chance of doing it. Well, exactly a 50% chance. All right, and that's that. We've added an equal chance of straight line corridors and nearest neighbor corridors, and 50% of the time it will spawn entities in hallways. That is it for both room builders and better corridors. Next time we're going to look at doors and maybe decoupling the map. I would almost want to do doors today because it's been very short, but I kind of like sometimes getting the shorter one. We'll see how doors go next time, and then I might do the decoupling map size. I think that one's a little beefier. but I'm really excited about it because we're going to be building a camera and everything. But let's just kind of keep doors in mind. Door placement. Are we going to actually be able to like interact with them? They just automatically work? How's it going to work? Making them do something? Yeah, we're going to get back to the ECS or something? Yup. A little bit more ECS work going on there. We're probably going to have to add stuff to our map saving and loading. Those big macros, which has been a hot minute. Visibility system. Yeah, this is going to be a good time. Handling doors. We could add an open and close command, but we're just going to have them automatically work. Too many doors. Cool. I'm really looking forward to this one. It's going to be a lot of fun. We'll do that next time. Thank you to anybody who showed up today, whether you are lurking or chatting. I do appreciate it. I do like these coding streams. We're just right here at the tail end of the map generation section of all of this. So then once we finish this here within the next 1, maybe 2 sessions, it's going to be onto the making a game section, which is going to be basically putting everything we've done together, adding some new functionality like experience and all that, but it's going to be pretty exciting, kind of piecing these things together and really getting into more game design elements of it rather than algorithms and stuff. And the algorithms is probably what I was most excited for, but game design is really important, and seeing how we can, you know, get some insights from this tutorial here, I think will be really helpful. So looking forward to getting to that pretty soon. Data-driven design, data-driven spawn, that's going to be a lot of refactoring, but it's going to be really good. I'm excited. Yeah, that's enough of that, though. Enough of me rambling on that. So again, thank you to anyone who showed up. If you are new and you like this, you like programming streams, you like Rust, you like roguelikes, all that stuff, that's cool. I also do gaming. I am currently playing on stream Caves of Cud, Dwarf Fortress. I'm going through the entire Metal Gear Solid series, and I do Genshin Impact every Sunday night. So if you like any of that or any other games, because I do play all kinds of stuff, you can follow me here on Twitch and come hang out for some of those. Really appreciate it. You can also go on over to YouTube, where all of my VODs, all my streams go up 2 weeks after they're live here on Twitch. Or if you're watching this in the future on YouTube, by the way, congrats on being in the future. While you're over there, I'd like if you could do all the usual stuff, like, subscribe, notification bell, leave a comment. I do read and respond to my comments there. I really appreciate them. Lastly, you can also follow me on Twitter if you want to see when I go live. I do tweet when I go live. That's almost all I do, that, and I retweet like adorable foxes occasionally and stuff, fennec foxes and stuff like that. But it's almost nothing but me just saying when I go live. So if you follow me there on Twitter and hit the notification bell, that's another way to see when I go live. I've had people in the past complain that Twitch notifications are slow. So there, that's an option. All right. So I will be back with more of this on Wednesday. Or do the doors and maybe decoupling the map size and all that cool stuff. And then I will be back tomorrow with some Dwarf Fortress, where my Diluvian machine is ready. And I'm probably going to go for about 2 hours tomorrow getting ready for enemies, and then 2 hours after I turn enemies back on, and we'll just see what happens. It should be a lot of fun. Alrighty, and thank you for hanging out, Rose. I appreciate it. And until next time, have a good day, have a good night, whatever it is, wherever you're at. Take it easy.
You must continue your mission.